So today we will discuss about graph traversal, BFS and DFS search. So here we discuss about BFS and DFS with various example. So breadth first search and depth first search are the two algorithms used for traversing and searching a node in a graph. So they can also be used to find out whether a node is reachable from a given node or not. So note that graph traversal, also known as graph search, refers to the process of visiting, checking, and or we can call updating each vertex in a graph. Tree traversal is a special case of graph traversal. So now the BFS and DFS searching technique is shown by an example. This is look like as. So for BFS and DFS, two traversal 2 point is maintained for solving the problem. These are visiting a vertex, that means going to a particular vertex, and exploration of vertex means if I have in a particular vertex, then visit the all adjacent vertex or edge of them. So next, based of two terms or points we can understand the traversal. So now by this particular example, at first we understand BFS, that is shown in figure. So here we can select any vertex as a starting vertex. So here we can select the starting vertex as vertex 1. So when we visit the in vertex 1, we can explore all adjacent vertex or edge that is connected here with vertex 1. So we take any of them first. So here we choose at first vertex 2, then vertex 4, and then vertex 5. So next we visit vertex 2 and find out which are connected with vertex 2. Then this particular vertex then we have to explore. So here we take first in vertex 3, then vertex 6, and then vertex 7. So BFS for this particular graph is means the path is 1 2 4 5 3 6 7. So here we can create many path. So I can solve by selecting starting vertex at vertex 1, and we can solve by this only. So this path also be corrected. So here all the vertices are visited and there have no vertex remains for exploring for this particular example. This is called BFS. So now next we can discuss about same example, DFS. So next by this particular example we can understand DFS. So that is shown in figure. So here also starting vertex we can consider that vertex 1. Then I have starting exploration. So from vertex 1 we go to vertex 2, and then and the other adjacent vertices are vertex 4 and vertex 5. So vertex 2, the adjacent vertex is vertex. So vertex 1 adjacent vertex is 4 5 and 2. So we can go to for vertex 2 only, and the other adjacent vertex are vertex 4 and vertex 5, but here we cannot visit vertex 4 and vertex 5. In DFS, when we go from vertex 1 to vertex 2, or all then only explore the vertex 2, or we can say the new vertex, that is visit first from the starting vertex. So here only we can explore the this particular vertex, new vertex. So next we explore vertex 2, then this is also explored, this also explored. So here from vertex 2, 3 adjacent vertex is explored. So here if I go for vertex 2 to vertex 3, then also you cannot visit other adjacent vertex like vertex 6 and vertex 7. So then again we explore vertex 3. So from vertex 3 have no adjacent vertex is there, so you can back to vertex 2 and explore the two vertices, that is vertex 6 and vertex 7, that is not visit previously. So like that next we can explore vertex 1 and by visit previously now not visited vertices, that are vertex 4 and vertex 5. So DFS for this particular graph is means path is like that 1 2 3 6 7 4 5. So in DFS also you can draw many path. So I can draw this path only. So in DFS once we started exploring, or once you visit a new vertex, we will suspend the other adjacent vertex of starting vertex and explore the new vertex only. So this called as DFS. So now we take another example for discuss about BFS and DFS in detail. So it's look like as first we discuss about BFS. So for performing BFS, we take a data structure that is Q, which is shown in figure. Now, so here we choose starting vertex is vertex 1. So in diagram answer part or BFS part we filled up by 1. So when we choose the starting vertex as 1, so here also Q also you can take 1, and then BFS part or answer part we also take as 1. So in tree or graph part we draw 1 and add this vertex in Q. This is an initial part, then take out the vertex 1 from Q, then we can take out, means this sign we can, by red sign we can filled up this point, that is it can be take out from Q. Then and Q and explore it. So from vertex 1, two adjacent vertices have explored. These are vertex 2 and vertex 4. So you can see that in this diagram, that is vertex from vertex 1, two edge or two adjacent vertex is there, that is vertex 4 and vertex 2. So first we will visit vertex 4. So add it into BFS and add it into Q and draw the vertex 4 from vertex 1. Then next we will visit vertex 2, same like as add it into BFS and add it in Q and draw it the vertex from vertex 1. So vertex 1 is completely explored because there have no adjacent vertices or remains. So next so now we select next vertex for exploration Q, that is 4. Then take out the vertex 4 from Q and explore it. So from vertex 4 one adjacent is there, that is vertex 3, so connect them into graph or tree from vertex 4. Then in by BFS part you put 3, then write on it into Q, that is 3. So vertex 4 is totally completed because there have no adjacent vertices there for exploring. So like that you can complete all the vertices. Then it's look like as that. And here the last, the total tree is when we develop the tree is called as BFS spanning tree. So this is the result, that is 1 4 2 3 5 8 7 10 9 6. This is the result. Then next same example we can solve the DFS. So second we can discuss about DFS. So for performing DFS we take a data structure that is stack, which is shown in figure. And so for BFS we can take Q, and for DFS we can take stack. So here if starting or initial vertex is 1, so in BFS also we can take starting vertex as 1, and DFS also we can take starting vertex as 1. So in diagram part, in DFS part, put it as 1. So you already know that DFS have another strategy, that is when we explore from vertex 1 to their adjacent vertices, so only one adjacent vertices can be explored, others cannot be explored, and these vertices can be explored many other adjacent vertices, then only there also we can choose any one of the adjacent vertices. So this is the main formula of DFS. So DFS part put is as 1. Next we start explore the vertex 1. So from diagram we see that from vertex 1 two adjacent vertices are explored, that's our vertex 2 and vertex 4. So here I can choose as vertex 4 and draw a diagram. Now by the rule of DFS we can explore the vertex 4, and the vertex 1 you have to suspended it and put into the stack for explore it in later. Now we visit from vertex 4 to vertex 3. So vertex 3 is put into DFS, then suspend the vertex 4 and explore vertex 3. From vertex 3 to go on vertex 10, so suspend vertex 3 and explore vertex 10, but vertex 10 have no exploration, so go to again vertex 3 from stack and go on to vertex 9. Then also vertex 9 have no exploration, so go to again vertex 3 from stack, then again exploring the vertex 3 and go back to vertex 2. So here we can see that from vertex 3 there have two exploration, that is 10 and 9, but from 10 and 9 nodes there have no exploration, so we cannot go anywhere. So for go back, we can go back to 3 and then again check here if any connection is there from 3 to any other vertices, so adjacent vertices, that is connection is there, that is 2. So here we can go for 2. So 10 9 we cannot develop any vertices from there, but 2 is now we can develop other vertices also. So like that you can draw this tree, that is DFS spanning tree, so using stack for formula. So the total, so this type also the DFS also completed. So note that the for BFS and DFS both method have same time complexity, that is order of n. Here n is the number of vertices. So we can conclude our lecture. Thank you very much.